There is some property in carbon due to which very complex molecules can be formed, and that's why we can have complex species, and that includes us, humans. What is this property which is there in carbon? You know that there are several elements present in nature. If you look at the periodic table, you will find many. In that, you will find carbon also. Carbon is somewhere in the middle, not strictly, of the periodic table. And it has got tremendous capability to bond with others, and that includes one carbon with another carbon also to an enormous extent. Because of this capability, carbon is capable of forming huge chains. If you look at molecules like hydrogen, oxygen, nitrogen, or bigger ones also, say when we talk of HCl or H2SO4, then these are nothing if you talk about a sugar molecule. And just if you imagine about protein, DNA, then we are talking about enormous difference in the sizes. Whether you talk about protein, or you talk about DNA, or you talk about glucose, sugar, fructose, the backbone is carbon. There may be other elements present. Glucose has good amount of oxygen, sugar also has good amount of oxygen. There may be other elements present. Protein may have nitrogen. There may be other elements, but the backbone is due to carbon. This property of carbon, that it is so friendly in forming bonds with others, makes such complex molecules possible. And you know that complex beings have several complex functions. A body has so many functions going on simultaneously, we are not even aware of most of them. Such complex functions are possible because of such complex molecules that are present. And it is carbon that has this capability that such huge complex molecules can be formed. This capability is due to the valency that carbon has, which is 4. Carbon has got atomic number of 6. That means its electronic structure is 2,4. That means to have the octet, it needs 4 electrons. Losing 4 electrons is not very favorable energetically. Losing electrons to that extent is not easy. There are different types of bonds that are present in nature. Why do we have bonds at all? What do we mean by bonds? It is seen that the elements that I was talking about, some of which are rather inert, rather happy on their own, it is seen that these elements have mostly got 8 electrons in the last shell. In fact, barring helium, everybody has got 8 electrons in the last shell if we talk about inert gases. These are rather happy on their own, aloof, not really eager to react in general. So a rule came up called octet rule, that even others want to be like inert gases. These are like role models for others. So whether it is hydrogen, or it is chlorine, or it is sodium, or aluminum, anybody for that matter wants to be like inert gas. So what is the concept of bonding? In nature, generally you don't find single type of atoms living alone, generally speaking. If you look at water, it is not one type of atom living alone. Water is H2O. So there are two types of atoms. Hydrogen has one type, oxygen has another type, and when three atoms are able to come together, then you get water. You look at oxygen that you breathe. In fact, you breathe more of nitrogen than oxygen. Whether you look at nitrogen or oxygen, it is one oxygen atom, another oxygen atom. Two oxygen atoms you breathe when you breathe one molecule of oxygen. Likewise, when you breathe one molecule of nitrogen, you are breathing two atoms of nitrogen at the same point of time. What I'm trying to say is that most cases you would find that single types of atoms are not there. And that's because atoms want to be like inert gases. They want to have 8 electrons in their outermost shell, generally speaking. How can an atom reach this aim? Its aim is clear. I want to get 8 in my last shell. So how is it possible? Atom has got some choices depending on its electronic structure. Depending on its electronic structure, it has got some choices. Sodium atom, for example, has got one electron in its last shell. Do you remember what is the electronic structure of sodium? Sodium is 2,8. 2,8. Is it 1? Two at 1. That means for sodium, losing one electron makes sense. Losing one electron makes sense. Okay, so sodium would like to lose one electron. On the other hand, if you look at something like chlorine, then the situation is completely different for chlorine. Chlorine is 287. Losing 7 electron is very difficult. Things should be favorable energetically. Losing 7 electrons is not favorable energetically for chlorine, but gaining 1 electron is easier for chlorine. Gaining 1 electron is easier for chlorine than losing 7 electrons. So chlorine would rather take 1 electron. So chlorine would rather partner with sodium, who is willing to give 1 electron, and chlorine would take it. So when we have give and take of electrons involved, then what do we have after this give and take? After this give and take, we don't have atoms anymore. Chlorine atom, after accepting electron, has become what? Chloride ion. Sodium atom, after losing electron, has become sodium plus ion. Sodium plus is called a cation. Cl minus is called an anion. Chloride anion. When we have got these ions, sodium plus and chloride minus, then there is Coulombic force. I think we talked about it in physics. 2 charges applying force, K Q1 Q2 divided by R square. Exactly the same thing. So between these two, Na plus and Cl minus, we have K Q1 Q2 divided by distance square force, and that force binds them or keeps them together. This is a type of bond called ionic bond. This is one type of bond called ionic bond. In case of ionic bond, you basically have ions everywhere. Atoms are not there. So once you have got ions, to get ions, you must lose electrons somewhere, and you must gain electrons somewhere. And then these ions would apply forces on each other using that Coulomb's law, which we discussed in physics. Actually, compounds formation is basically physics. It is everywhere electric force. Positive charge, negative charge, applying force. The existence of atom itself is due to physics. You know Bohr's model, electrons revolving around the positive nucleus. So it is the Coulombic attraction force that provides the centripetal force, and that's why atom can live. But now we are talking something more than just one atom. We are talking about one atom combining with another atom. So one possibility is that you have ionic bond. But for ionic bond, one fellow should dislike electron, like sodium, and other fellow should really love electron, like chlorine. Extreme cases. It's like hate and love type of case. Only then can you have ionic bond. But many times it happens that neither the dislike is very strong and nor the other case. Not so extreme cases. In that case, what can happen? Say for example, something like methane. Or let's make it easier. Let's talk of something like hydrogen gas. Hydrogen gas. Hydrogen gas is one hydrogen atom, another hydrogen atom, they are combining. Okay, one hydrogen atom, other hydrogen atom, they are combining. Now, why would one hydrogen atom lose electron and the other hydrogen gain electron? One hydrogen atom does not hate electron more than the others. They are all identical. All hydrogen atoms are identical. It's not like sodium and chlorine. They were so poles apart. One really wanting to get rid of electron, one is eager to accept electron. Two hydrogen atoms are identical. Why would one of them say, I would take electron, and why would others say, I would lose electron? So, in case of hydrogen molecule, H and H, when they come close, something else happens. Firstly, it's not going to be 8 electrons. As I said, helium is also an inert gas, and helium has got 2 electrons in the last shell. So hydrogen wants to be like helium. Hydrogen doesn't want 8. Most of the times it is 8, but sometimes it is like helium, which is 2. Lithium also would like to be like helium. Hydrogen also would like to be like helium. So what do these two hydrogen atoms do then? Share. They share. Partnership. Partnership of not give and take type, but sharing type. Okay, I have one. You also have one. Hydrogen has got 1 electron, right? So both of them say, well, each one of us has got 1. Why not just share? Not give and take, but just share. So this hydrogen has got 1, this hydrogen has got 1. Generally, electron is supposed to revolve around one nucleus. If you talk about one atom, then electron of that atom should revolve around the nucleus of that atom. Correct? When they say, both of them, when they say that, well, I have one, you have one, let us share, then it means that now the electron which was revolving around one nucleus, that electron will have to revolve around two nuclei. So if we simply say path of electron was simply round and round and round, it will no longer be round and round and round. It will become complicated. Now there are two nuclei at some distances, and each electron will have to revolve in such a way that both of the nuclei are happy, that electrons are revolving around both of us. That's the meaning of sharing. So when you look at hydrogen and hydrogen, then they share electrons, not give, take. When you look at oxygen molecule, that is oxygen gas basically, then there also it is sharing which is involved. The reason is same. Why would one oxygen atom hate electrons more than the other oxygen atom? They are all identical. So why would anybody give and others take? So they share. Think about nitrogen, N2 gas, nitrogen gas. One nitrogen atom, another nitrogen atom. Again the same story. Why should one give, other should accept? If one is extreme hater and other one is opposite, extreme opposite to that, then it will be ionic bond, like sodium chloride, the salt that you eat, or potassium chloride, or magnesium chloride. In all of these cases, one fellow is extremely desperate to lose electron or electrons. Other fellow is desperately eager to accept electron or electrons. But when this desire is not so extreme, then we have this type of partnership taking place, that okay, you take, I give you, I have one, you have one, let us share. Or I have two, you have two, let us share these four. Four sharing is also possible. So one fellow contributes two, other fellow contributes two, 2 plus 2, 4 electrons are shared. That's possible. And all of these 4 electrons will revolve around both nuclei in a big region. Then there can be even much larger sharing. There can be 6 electrons that are shared electrons, 6 electrons. So one atom says, okay, I give 3, I contribute 3, I contribute 3, you contribute 3, total makes it 6, and let's have these 6 electrons revolve around both of us. Both of us means both of the nuclei belonging to the 2 atoms. Right? So when there is such partnership, contribution, then this type of bond is called covalent bond. Covalent bond. When it is give and take, it is called ionic bond. In case of carbon, it is 2,4 type of situation. 2,4 type of situation. There is a desire for force. Losing 4 doesn't work well. Accepting 4 doesn't work well. In case of carbon, it is almost always covalent bond. In organic chemistry, most of the times you will see covalent bond. Now I might have given examples of similar types of atoms, whether it was example for hydrogen gas or oxygen gas or nitrogen gas, similar types of atoms everywhere, H, H, O, O, N, N. It doesn't have to be so all the time. Think of methane gas, CH4. CH4. 1 carbon and 4 hydrogens. Neither carbon nor hydrogen is an extreme electron hater, or the opposite. Carbon and hydrogens agree. Okay, let us share one. If one carbon shares one electron with hydrogen, then carbon won't be happy because hydrogen has only one electron, carbon has 4. Outermost shell I'm talking about, carbon has 6 otherwise. 4 electrons carbon has, 1 electron hydrogen has. If they form a team, 5 electrons carbon is not happy. 8, it wants 8. Hydrogen may be happy. Carbon contributed 1 electron, hydrogen contributed 1 electron. 2 electrons hydrogen has got. These 2 electrons are revolving around its nucleus. Hydrogen is rather happy, not carbon. So carbon will form one more bond with another hydrogen atom, right? So that another hydrogen atom will contribute 1 electron. Carbon had 4. One hydrogen atom contributed 1. Another one contributed 1 more. So that means 2. 4 plus 2. 6. Not good enough for carbon 6. It wants 8. So third hydrogen atom, again 1 electron contribution. That makes it 4 plus 3 equal to 7. And then we have the fourth hydrogen atom contributing 1 electron. So 4 hydrogen atoms contributing 1, 1, 1, 1 each. 4 overall contribution. Carbon has got 4. Now carbon has got 8. These 8 electrons are revolving around the nucleus of the carbon atom in some complicated manner. But it has got 8. So that's why we have got something like methane molecule. So in methane molecule you find 4 covalent bonds. Carbon hydrogen 1, carbon hydrogen 1 more, carbon hydrogen 1 more, carbon hydrogen 1 more. There are 4 bonds. Each bond is called carbon hydrogen bond. So in case of organic chemistry, most of the times you will see this type of contributions, and electrons that participate in these contributions, they are poor fellows. They have to revolve around both of them. But all electrons are not like these. For example, when we talk of carbon 2, 4, these 2 are inner electrons. 4 electrons are outer. Inner electrons, no participation in bonding. So they are not going to go around other atoms' nucleus. They won't be going round and round other atoms' nucleus. So these internal 2 electrons are going around that local nucleus. The 4 electrons, now their job is now bigger. They have to satisfy this carbon also, and they have to satisfy those hydrogens also. So they travel in a much more complicated path so that both atoms can be happy. Both have got 8 in the last shell or 2 in the last shell. Generally we call the rule octet rule. Oct means 8. But for atoms like hydrogen, lithium, helium inert gas is closer. Helium is closer. So for small atoms, it is not 8 octet, but it is 2. But there are fewer cases, much fewer cases, and therefore the word octet has become very common, and everywhere you would hear why there are chemical reactions, why is there any bonding, and you will hear the answer, octet rule. But sometimes it may not be octet rule. It could be just 2 electrons. Okay, any questions? Let me know.
Sir, how exactly does the hydrogen molecule look after bonding? You said they share electrons. How does it exactly look?
How does hydrogen molecule look like after bonding with shared electrons? This was the case earlier. This electron revolving here, this electron revolving here. After the bonding, these two electrons revolve around both. How would it actually look like?
So they will revolve in an oval shape.
Okay, if you're asking which shape they revolve, if that's what you're asking, then the answer is that depends on case-to-case basis. There is a concept of, you know the concept of atomic structure in which electron revolves around atom. When molecules are formed, now this is called orbit. When molecule is formed, then there is something called molecular orbital. Molecular orbitals have got different energy levels, and if I talk about that, it would be complicating it too much. But just to give you an idea, just think of something called molecular orbital, and shape could be like this, but that may not be so in all cases. Molecular orbitals may have different types of shapes, just like atomic orbitals have got different types of shapes. Now you must have learned only something like circular type of thing, but the fact is that even in atom, it is not always circular. There can be complicated situations within just one atom also. So molecular orbitals also may have different types of shapes. Alright, now I think I will have to stop. As this is the time for the next class. But I will quickly give you an assignment. Suppose I tell you that water has got only covalent bonds. Suppose I tell you that water has got only covalent bonds. Then can you tell me how sharing would be taking place? How sharing would be taking place? You can give your answer in just 2-3 sentences. That should be enough. I hope the question is clear. Otherwise, let me know if some clarification is required. So you have to tell How many electrons are shared here? And how many electrons are shared here in water? Bond is only between oxygen and hydrogen. There is no bond between hydrogen and hydrogen in water. Okay? We stop now.